Geometry notes on reflections. A reflection is a transformation that flips a figure over a line. When a figure is reflected, the image is still congruent to the pre-image. So if we're going to reflect triangle ABC over the x-axis, what does that mean? Well, what that means is if A is 2, 3, and B is 4, 7, and C is 7, 2, then if we reflect over the x-axis, the x values are going to be exactly the same, 2, 4, and 7, but the y values are going to become negative. So, -3, -7, and -2. -3, -7, -2. The rule for reflecting over the x-axis is xy maps to x -y. Now sometimes we reflect, of course, over the y-axis, and what does that look like? What that looks like is, well, let's see, if D is -7, -7, 8, and E is -8, 2, and F is -2, 3, and we're reflecting over the y-axis, then we're flipping this guy from here over to here, and now the y values stay the same, 8, 2, 3, but the x values change. So now we have 7, 8, 2, 4, 6, 7, 7, 8, 8, 2, and 2, 3. Now the difficulty we have here is that no one ever asks us such a simple problem. Usually they will give us a much more interesting problem, such as given a triangle COW, we're not going to reflect over the x-axis. We're going to reflect over perhaps y equals x. Well, the first thing we have to do in this case is going to be to draw the original triangle. -8, -6, -7, 3, -3, -3. So we begin with COW, just like that. Well, now what's going to happen? Well, if we have to reflect over y equals x, which is the parent linear function, we have to figure out what y equals x looks like. Well, if x is 0, what is y? Well, if x is 0, y is 0. If x is +3, then y is +3. 2 points make a line. So now, here is my y equals x. Here is my graph y equals x. But if I'm going to reflect over this line, then, well, now this is kind of lucky. Look at this. W is on this line, so W prime is going to be exactly the same. -3, -3. But what am I supposed to do about C, for example? Well, it's left 1 and up 1, so I must go right 1 and down 1, and that's going to give me C prime. So if C were -8, -6, C prime is going to be -6, -8. Oh, am I seeing a pattern? I could be, but I'm not sure. Now what I need for O is, well, let's see, what is O? O is -7, +3, so O prime must be +3, -7. +3, -7. Do you see what the rule was here? For this mapping, we changed x and y. That's the algebraic explanation. So here we have triangle C prime, O prime, W prime, that looks like this. Now, you think that this may be the only time you ever would be seeing this? Oh, not true. You have lots of these sorts of transformations in Algebra 2, in matrices, and it becomes very, very important in calculus. And every scientist and engineer has to take a couple of years of calculus. So we have seen three kinds of reflections. A reflection over the x-axis, that's pretty straightforward. A reflection over the y-axis, that's pretty straightforward. And this really interesting reflection across y equals x. You'll see this also again in inverse functions at the beginning of Algebra 2. And inverse functions are wonderful. These problems show up in algebraic form on the SAT as well.